Welcome to today's class. Let's look at yet several examples for the last 10 years questions under Newton's law of gravitation. Put on please. Example 1 says two particles of masses 0.20 kilogram and 0.30 kilogram are placed 0.15 meter apart. Full stop. A third particle of mass 0.050 kilogram is placed between them on the line joining the first two particles. Calculate the gravitational force on the third particle if it is placed 0.05 meters from the 0.30 kilogram mass. So the keyword there is calculate the what? Gravitational what there? Force on the third particle, right? So first things first, in science, your first task is to list out the givens, please. Given parameters, please. First things first, two particles in that question, please. Obviously, in that question, if I'm to open my eyes very well, I have three masses there. So give me M1, M2, M3. M1 is of course the first mass there, that's 0.2 kilogram. In the question there, I have 0.20. 0.20 and 0.2 are literally the same thing. So I have 0.2, that's M1. M2 is of course same thing, 0.30. I can omit the last zero. I can write 0.3 kilograms, still correct. Finally, please, what's your M2 there? My M2 is at the last part there. Check the last part there. M2 is what? M3 is 0.05. So 0.05 what there? Kilogram. I have drafted out all the masses in the question there. Now listen from the beginning. It says two particles of masses M1, M2 are placed 0.15 meter apart. So the distance here, listen up please. Okay, hold on. Let's spend distance for now. A third particle of mass, that's valid there, is placed between them on a line joining the first two particles. Here is a concept. To get the in-depth understanding of this question there, I'll have to mask out the diagram that will illustrate this. What do I mean? Look up please. First things first, given two particles, let's say the first particle here, M1 is here, and of course, my M2 is here. And they said I placed 0.15 meter apart. So I'm saying the distance from here to this point is what? Is given as 0.15 meters. Next up, they said that a third particle of mass 0. This is placed in between M1 and M2. Let me put it here. So the mass 3 is placed in between M1 and M2 such that the distance of that the distance from M2 to this M3, please, M3. So observe the word they use there. They said calculate the gravitational force on the third particle if it's placed 0.05 from the 0.30 kilogram. That's your M2. So from here to here, I'm saying that the value is given as 0.05 meters. So this is what you are asked to do. This becomes the diagrammatic illustration of that question. Here's the concept, please. Here's the concept. If M3 to M2 is this value, what exactly is M1 to M3 or M3 to M1? It's as easy as subtracting the value 0.15 meter from what? 0.05 meters. This will give us 0.1 meters. So of course, I'm saying that from here to this point here is 0.1 meters. All right, this is my question analysis. I'll not start solving. I'm just trying to explain this concept well before I start solving. All right, let's now get into solving, please. Let's solve this problem. It says that calculate the gravitational force. So on the third particle, please. So here's the concept, please. To find the gravitational force on the third particle, neutrally, we know that force F is what? G m1 m2 over r squared. In this case here, I have m3. If I have m1 m2, I will have used this formula there and go. But I have m3 here. So how do you solve this problem? It's a task. I'll look for two forces here. After finding the two forces here, I'll add them up. That is, I'll pick F with m1 and m3. I'll pick another F with m3 and m2. So the force for m1 m3 and the force for m3 m2, I'll add them together. That will give me the total gravitational force I'm looking for. That's all. So I'm saying that I'm going to equate my m1 and m3 first. So I'm saying that the first force, perhaps total force, is equal to what there? The first force plus the second force. In my first force, I'm considering m1 and m3. In my second force, I'm considering what there? m3 and m2. All right. So let's get it done, please. Let's get f1. Sorry, first force. It means that f1 is equal to g m1 m3 over r squared. All right. So the r means distance between m1 m3. So m1 m3 is 0.1. So from here I'll have that the force at my first section is equal to g is of course constant 6.67 times 10 to power minus 11. That's my g. Next up, m1 is of course m1 0.2 into 0.2. Next up, what's m3? Of course 0.05. 0.05. So all over r squared. Distance between m1 m3 0.1. I have 0.1 all squared. If I'm to punch my calculator from here, I should have a value that looks like all right. So if I'm to punch here very well, my f1 should give me 6.67 times 10 to power minus 11. All right. So if I'm to point this very well, I should have that value as my f1. So that's my f1. Let's get f2, please. Let's get f2. To get f2, it's easy. We said f2, you are considering what the mass 3 and mass 2, such that the r here is different. The r is from here to here, which is what? 0.05. So I'm saying that f at section 2 is equal to g m3 m2 over what the r squared. From here now, my force at 2 is equal to capital G is said 6.67 times 10 to power minus 11 into what's m3? That's 0.05. 0.05. What's m2? M2, that's 0.3. All right. All over, what's r squared here? What's r? R. from here to here, because we're using M3, M2, that's 0.05. 0.05 over there, all squared. If I'm to punch my value correctly for F2, I should have that F2 should be equal to 4.004 times 10 to the power minus 10. So I'm saying that F2 is equal to 4.00, alright, times 10 to the power minus 10. Of course, my force should be in Newton. My force here should be in Newton. So to get total force here, so my total force, Ft, total force, is equal to F1 plus F2. What is F1? What's F2? F1 is, of course, 6.67 times 10 to the power minus 11 plus, what's F2? F2 is, of course, 4.00 times 10 to the power minus 10. Alright, so my total force should be equal to, if I had 6.67 times 10 to the power minus 11 plus 4.00 times 10 to the power minus 10, I should have that my answer should be 4.67 times 10 to the power minus 10. Of course, my answer should be in Newton because it's force. So it becomes my force of attraction. This is how I calculate this particular question. So this is how I calculate this question. So if you found this class helpful, do well to like the video, share to your friends and classmates, and leave a comment. Also subscribe to my YouTube channel. Next up, if you're interested in getting full and over 250 plus tutorial video on mathematics, chemistry, and physics for JAMB students, you can do well to, as you can see the screen here, you can do well to check out for my membership opportunities for JAMB and WAEC students. It's of course 1,000 naira. You can purchase the course. You have access to 250 plus video on chemistry, mathematics and physics, and other science courses there. Also do it to visit my website at www.ghanabakari.com. For the courses there, on my website you get full access to tutorial courses for sciences, right? So do well to visit my website to get those courses in affordable price, and then from there we'll learn together. Also do well to join my WhatsApp group, right? The link to my WhatsApp group is at the description of this video, so do well to join my WhatsApp group. Alright guys, see you in our next class. Oh, look at yet several other examples involving the study of Newton's law of gravitation.